Hello everyone, and thank you for watching this video. My goal here today is for you to see why we have 4 seasons on Earth. What I have set up here is 4 globes. Now I don't want you to think that we actually have 4 Earths going around the sun in the sky. Actually, each of these Earths is representing a current position as the Earth revolves around the sun. In the middle, the light bulb is going to represent the sun. Now I understand that this light bulb should be millions of times the size of the Earth, but for our purposes, this will serve fine. So I have these 4 globes set up here. We have to know that the Earth is tilted. Without tilt, we're not going to have any of these seasons at all. The Earth will be pretty much one steady temperature. I've done my best to make each of these globes tilted the same way. If you could zoom in on the equators here, you can kind of see that all of them are tilted in the same direction. That's going to be important because in the sky, the tilt never changes. Instead, the Earth's position around the sun changes, which causes the various seasons. So, first of all, we have to establish this. The equator separates the northern and southern hemispheres. We live in the northern hemisphere, so South Brunswick, New Jersey, located in the north. The southern hemisphere is opposite of us, so whatever we experience, they're going to experience the opposite. However, the Earth would never look exactly like this because of that thing called tilt. So realistically, the Earth would be tilted to look more like this. Now, another important feature of seasons is something we're going to talk about called direct versus indirect sunlight. Basically, certain parts of the Earth get hit with more direct or indirect sunlight throughout the year. Let's go first to this globe right here. If we could zoom in on this globe, we can tell that the globe is tilted so that the northern hemisphere up here is tilted away from the sun. The southern hemisphere is getting more direct sunlight, or more concentrated sunlight. Therefore, there we're very warm and heating up in the south. We're having the opposite effect, which means it's our winter in the north. It's always the opposite. Northern, winter, southern, summer. Okay? Because again, they're getting the direct sunlight or the more concentrated sunlight. We're kind of getting the leftovers. Now also keep in mind that this globe will rotate every 24 hours, causing night and day, but that does not affect our seasons. That's night and day. Now, this would be northern hemisphere, winter, cold. Southern hemisphere is getting the more direct sunlight. Okay, we're cold where we are. Now, the Earth revolves around the sun counterclockwise. So this would be the next globe that we go to. Now, if we zoom in on this globe, in this situation, neither hemisphere is getting the direct sunlight. It's kind of fair between them both. Therefore, the southern, which was getting it, is now warm, is now cooling down, and we in the north, which was not getting it, is heating up a little bit. They're cooling down, we're heating up. Therefore, if we're heating up after winter, we go to our spring. Heating up, we are getting more direct sunlight than we did in winter. Next, we move here. Now in this situation, it's the exact opposite of where we started. Now the north is getting the direct sunlight because we're leaning towards the sun. The southern hemisphere is getting the leftovers or the indirect sunlight. Therefore, we've heated up completely entering our summer, and as we said with opposites, they'd be having their winter in the southern hemisphere. So northern hemisphere summer, southern hemisphere winter. We're warming up, they're cooling down. Just pause for a second. Our last globe, we just left summer, therefore now we're both getting kind of equal amounts of direct sunlight again. Therefore, we're going to be cooling down in the north. The southern hemisphere will be heating up, therefore we're entering our fall. The southern hemisphere would be entering the spring. We're cooling down, southern hemisphere is heating up. So basically, what we have going on here is direct or indirect sunlight affects which hemisphere is having their summer or winter. If the hemisphere is getting direct sunlight, such as in this situation, the northern hemisphere is getting direct sunlight, we'd be having summer in the north. If the southern hemisphere is getting direct sunlight, they'd be having their summer. Direct sunlight equals summer. Indirect equals winter. However, you have your in-betweens where you're going to have your springs and falls as well. Now, there's always a couple special situations. We have these things called solstices. We have the summer solstice in the north, which is June 21st, and the winter solstice in the northern hemisphere, which is December 21st. These solstices mark the beginning of a season. The winter solstice, the first day of winter, summer solstice, the first day of summer. These are special days where, on these days, we have the most daylight or the most darkness of all year, depending if it's the summer or winter solstice. Currently, we're almost going to be entering, well, this is the summer solstice for us. This is our winter solstice here. This is kind of where we're going to be soon. The southern hemisphere is going to be having their summer solstice. We'll have our winter solstice. So we're going to have our shortest day of the year, daylight-wise, on December 21st. When we get to summer, we'll have our longest summer solstice day, longest daylight of the year. There's 24 hours in a day, so we basically have a lot more daylight than night on the summer solstice and darkness than daylight on the winter solstice. Then we also have a couple extra special days called the equinoxes. They occur in March and September. They mark the first day of spring and fall. Spring equinox would be here, and the fall equinox would be here. Basically, on these 2 days, we have exactly the same amount of daylight and nighttime, equal night and day, approximately about 12 hours of each. So again, to wrap up, direct sunlight versus indirect sunlight causes these seasons, in addition to tilt. No tilt, no seasons. Thank you.